Good afternoon and welcome. I'm Brent Donaldson, Editor-in-Chief for Modern Machine Shop. Today's webinar, brought to you by Mahr, addresses the challenges often faced when assessing contour features of parts and components. If your company struggles with the shape features of your parts and components, including distances, radii, and angles, you are in the right place. Today we'll tackle topics such as measurement capability, how measurement hardware works, software capabilities, and automated evaluations, and the CD140 alternative. Today's presenter is Nick Russo, product manager at Mahr, who started with the company 6 years ago as an applications engineer focused on installation, calibration, and operator training for large metrology systems. In addition to being a product manager, Nick is also the company's technical liaison for surface finish and contour measurements and applications. Please note that if you have questions at any time during today's presentation, you can type them into the Q&A panel on your screen, and we will do our best to answer them at the end. Also note that this webinar is being recorded, and you will receive a link to that recording via email after we're finished. So with that, take it away, Nick.
Yes, thank you. And thank you for everybody for joining and giving us your time today. I hope that you can walk away from this presentation with a bit more information that will hopefully be able to help you out with your quality requirements. So that being said, this will be our agenda for the webinar today. First, of course, what is the machine? What kind of fixturing capability we have? An overview of the probe and measurements, more capabilities such as exports, surface finish or roughness, being able to measure diameters, threads, or maybe the CD140A isn't quite what you need. What other alternative solutions are available to you? So this is a contour system designed for simple, quick, manual measurement tasks. You can use it in either production or laboratory environments. And this is the base scope of the CD140A. It has a 350 millimeter manual Z-axis, which you can use a handle here for the coarse adjustments. And you have a Z-axis fine adjust at the top of your column and another one at the bottom of your column. There is also a stop protection right here on the Z-axis so that when you're moving your entire carriage up and down, that you don't slam it in the drive unit into the table plate. You've got a 140 millimeter measuring X-axis and a 70 millimeter probe axis. Also on the machine is a table plate. You've got a micrometer in the front of the machine that moves this table plate in and out so that you can find the high points or low points of your samples to make sure that you are coincident with the drive unit. And this has 60 millimeters of range and is a 390 by 450 millimeter area plate. And then finally, on the sides, you've got two handles on each side for easy system movement. So the base machine comes equipped with a 50 millimeter on-center bolt hole plate, allowing you to reuse fixtures that perhaps you already have designed for CMMs, where the measurement features you're trying to get, CMM isn't quite the right tool for it. It also allows you to easily design new fixtures by having the 50 millimeter grid plate. So as an example, you can get an optional Delta block set, which allows you to design your own modular workpieces and fixture configurations. So once you have this fixture set, you can disassemble it and put it and make it into other styles of configurations depending on your workpiece. You can also use two stop rails that ensure that your generic vise, V, sign plate, or other fixture is in proper alignment with the drive unit, and that you are square with the probe to give you the best measurements possible. So the probe system is designed with just a simple 3-point magnet for easy probe swaps. There is a notch on the probe here, which only allows the probe to go in one orientation, so you can't put it in the wrong orientation. It will always be pointing straight down. The advantage here is that you can easily swap probes with the magnet, and you can swap them as often as you want without needing to recalibrate the probe. There is also an adjustable measurement force built into the Mahr software without the need for weights on your probe. So if your sample requires a bit lower measuring force because you're worried about scratching or deforming your samples, you can adjust that measuring force inside the software without the need for any weights or tools to compensate. These are just a few of the standard probes that are available for the CD140A. This 36 millimeter probe comes default with the machine, but let's say you need to get inside a bore that's a bit smaller than 36 millimeters. We have something like this that would be able to fit inside a 3 millimeter bore with a smaller stylus. Or if you need something a little bit larger, or instead of your standard chisel type probe, you can use a ruby 1 millimeter diameter ruby tip for a more mechanical filtering. As we begin to take a measurement within the Mahr software, we can create what we call a quick and easy, another word for a program, where we can include a guided operator sequence with as many pictures and instructions as you want to minimize error in measurement setup. We can program automatic movements of the probe in the probe axis and the x-axis to minimize the amount of time a measurement cycle takes. This way, the operator does not have to move the x-axis to the beginning of the start of the measurement. The automatic x-axis can do that for you. We can do automatic evaluation of profiles so that if you're measuring the same part over and over again, you don't have to repeat the same evaluation over and over again. Your evaluation will automatically populate at the end of your measurement. And then lastly, once the measurement is actually finished, we can do automatic export of measurement results in multiple different file types. So once we see a measurement here, we'll talk about some of the export capability. And that Mahr is universal. So if you already use Mahr on a different type of machine, like if you have a Mahr Surf or a Mahr Form machine and you're already familiar with that software, there's little to no learning curve because it's the same software package. So what you can see here is the manual z-axis moving up and down. You've got your fine adjust at the top and your fine adjust at the bottom. Your stop there so that the x-axis, the 140 millimeter x-axis, won't collide with the table plate. You've got your 60 millimeter table axis in the y direction there. And the probe tip simply comes off with a magnet like that. So once everything is in place there, we can go back to the software and begin to run the measurement routine. Once we gather our samples, gather our fixtures, and we're ready to go. So this is what the base Marwin software looks like. You can have all of your programs on the bottom here as a quick access shortcut. So this begins our guided operator sequence. It's telling us that the probe is going to move to a safety position, remove all of the samples, and manually position the z-axis to 10 centimeters. And you can have a picture there with the axis at 10 centimeters. This is your warning saying, hey, the x-axis is going to move. Make sure nothing's in the way. It then tells us to place the fixture at slot B4. Everything here is labeled in both the column and the row. Here you can enter any information regarding to the workpiece, job information, workpiece information, anything you want for your export. And as we move on, we're going to bring the z-axis a little bit closer to 7.3 millimeters and then begin the measurement. So the probe automatically moves to the pre-programmed start position and then begins the trace. And you will always see the live version of the trace on your screen so that you can see how it is looking before the measurement is actually completed. So once the measurement is complete, the probe arm will lift up and move out of the way to some pre-programmed safety distance, and you get your automatic evaluation of features at the end of the program. So once it's ended, what can we export? By default, we've got the measurement result PDF. This is the most common export that we use. You can enter your address here and put your logo here as well. Any information that we entered in the query can show up within the record header here. The first block here gives us all of the measurement parameters, all of the features that were used, what drive unit was used, what probe was used, information like that. And then it gives us our actual measurement. So you can see here I've put on a couple different features, put in a couple different radii, a couple angles, and a couple distances. Within the software, we can specify a nominal value and apply a tolerance to that value. By default, if the measurement is within your tolerance, it will show up green in both the chart and on your screen, in your evaluation screen. If your measurement is perhaps too small, this is your instant indicator whether the sample is good or bad. You'll see a blue bar here, and your tolerance in the measurement will also be blue. But again, that's default. You can change that to whatever color you like. Likewise, if your measurement is too large, you've got a big red bar here saying, hey, this feature is too large for the tolerance. It doesn't pass. Another thing to note here is that these green bars, they are proportional to where you are in your measurement tolerance. So if your green bars are fairly centered with the screen, that means your measurement was pretty close to the nominal value of the feature. But as we look at this, perhaps Z distance, this bar is green, but it's pretty close to my upper limit here. So it tells me, yes, I'm within spec, but I'm pretty close to being out of spec. I'm at the higher end of my tolerance range. And the same here with the X distance. Yeah, you're within spec, but you're pretty close to being too small. So these are all of your instant gratification that tells you whether the sample is with or out of spec. Something else that we can do with Marwin is we can import a nominal DXF of the sample. We can then overlay that nominal DXF with the measurement and see how far our measurement deviates from the nominal profile. So this is magnified 10 times. So it gives you an idea of where your sample deviates from the nominal and how much. And you can also create tolerance bands to define that limit of how far away from nominal you are willing to accept. So as we can import a DXF, we can also export a DXF. So once you take your measurement, if you want to open that into in a 3D CAD viewer, you can do that as well. You can also append history into an Excel file. So every time you take a measurement, it will input the values into a new row with a timestamp. And you can see how consistent your machining operation is over time. So we can set the file type as to append results instead of replacing the file type every time this measurement is performed. So it'll give you a running tally of what your measurement looks like over time. And since this is Excel, you can put in any other formulas for statistics that you may want to see. For example, if you wanted to have an average of all of my radius 1, that's my average for radius 1 throughout the entire span of it being measured. So you can do averages, standard deviations, range, whatever kind of statistical analysis you may want. The last one here be the raw data points. So we can export the individual raw data points in a text format. This gives you all of your typical header information that we saw in the PDF, and then gives you all of your individual raw data points, which can be delimited in Excel so that you can extract your X coordinate and your Z coordinate. We're not measuring in the Y-axis, so this will be 0 here, but it can be delimited to extract just the X and Z coordinates. So as far as other types of measurement capability, with a twin stylus, you can also measure diameters. And what I mean by twin stylus is that your typical stylus will only have a tip coming from below the shaft. We have tips that we have probes that have tips that come from below the shaft and above the shaft. So we can take 2 separate measurements, one contacting with the lower stylus here, and then another measurement contacting with the upper stylus on the upper end of the ring, and then relate those 2 profiles together to measure the diameter of an ID or an OD. And here are just some examples of the size of twin stylus probes that we have to offer, whether you need something a little bit bigger, around 30 millimeters, or something a little bit smaller, around 3 millimeters. So the CD140A can also measure surface finish, for example, RA and RZ. In general, you can measure roughness if your RA is greater than 1 micron and your RZ is greater than 2 microns. This is an additional software license for roughness capability. But for those surfaces that have perhaps both contour and roughness callouts, you can do both contour and roughness within a single stroke and not have to perform multiple measurements to get both contour and roughness results. And what you see here below is just a typical output of one of our measurement results evaluating roughness, and whatever parameters we have turned on for evaluation. And again, just a couple of different probe options here for surface finish. We are limited to a 5 micron diamond, but you can have it in either 90 degrees or 60 degrees. So we can also automatically evaluate thread features. So with a single stylus probe, you can measure flank angles, pitches, heights, straightness of flanks, and root radii. And with a twin stylus probe, this allows you to measure all of the above plus major, minor, and pitch diameters. So this is a typical example of what the thread software will output. This is a tapered thread that was measured, and you can see we have an upper profile measured with the upper stylus and a lower profile measured with the lower stylus. It gives us an overview of all of the measurement characteristics and a depiction of what those are representing. So we have our major diameter here, our pitch diameter here, and our minor diameter here. And you've got your pitch, height, and your flank angles here. The chart inherently gives you the mean values of all of those features, the standard deviation, minimum, and maximum. Then it will repeat that same image, but with your actual mean values of the measurement. So remember that in order to measure diameter, we have to have a twin stylus. So if you're measuring this with a single stylus, the diameter features will be omitted from the report, but it gives you all of your individual diameter results based on how many features you're able to capture within your measurement. So we've got our major diameter here, all of the minor diameters between the upper profile and the lower profile, pitch diameters, and if it's a tapered thread, you've got a cone angle as well. So now we're getting into individual profile evaluation instead of profile to profile evaluation. You don't need a twin stylus to measure a flank angle. So it gives us our two different profiles, our upper and lower profile of the flank angles. The upper and lower profile for all of the individual pitches. All of the individual heights. Straightness of the flanks. And root radii. Now you can perform these measurements manually within the software, but this additional script allows for very quick and easy evaluation of threads that will do everything automatically for you based on the nominal values that you input. So it's a big time saver with this script versus doing all of these evaluations manually and applying it to different measurements. So those are the main points of the CD140A. But if you have perhaps a need for something a little bit more than that, the CD140 or 280 could be an alternative. So you can have a 140 or 280 millimeter measuring x-axis, a motorized 350 or 600 millimeter z-axis column, and a large granite base with an optional isolation platform that will help you reduce the amount of data that you get from background vibration in your measurements. You also have an optional motorized Y-table axis. So this axis for the table can be motorized so that you don't have to manually move it back and forth. And you also have an optional touchscreen panel, control panel with a joystick that allows you to move all of the motorized axes from the joystick instead of via the software. So if you combine both a motorized Z and Y axis, this allows you to place a part on the machine, walk away, come back, and the measurement and evaluation will all be completed so that you don't have to do anything manually at that point. The motorized Y-axis helps with the ability of finding your high point or low point of the sample and making sure that you are in proper alignment with the drive unit. And another alternative would be the VD140 or 280. With this, you get all of the benefits that you get from a CD140 or 280, but this includes a dedicated higher resolution surface finish probe system, which you can switch quickly and easily between contour and surface finish measurements. So you've got one contour probe system and one roughness probe system, which you can remove depending on what task you need to complete. And again, you can swap them as many times as you want without having to perform any recalibration of the machine or of any probes that we use with the probe system. So that's all I have here. Any questions? We can discuss that now.
Very good. Thank you so much, Nick. And to our live audience, this is a reminder that right now is your opportunity to ask any questions that you might have. Please type them into the questions panel, and we should be able to address them. In the meantime, we have a couple in the queue here. Let's just start with something basic. Nick, how long does the machine that you were talking about today take to calibrate from beginning to end?
That's a good question. So typically we will use a 2-ball master where you measure the radius of about a 4 millimeter sphere and about a 22.5 millimeter sphere to determine the offsets of your probe and the radius of your tip. It will take you typically between 5 and 8 minutes to run through a full calibration for one probe. But remember, you can switch probes as many times as you want without having to recalibrate. So typically we recommend maybe about once a month probes be recalibrated just to make sure that you are measuring with a good tip.
Nick, you might want to, if you have do you have is your final slide, does it have your contact information, or do you have anything else that you want to put back on the screen so people can maybe reach out if they have any questions for you that they would
Sure, of
like to
course.
ask? And while you're doing that, let me look at the queue here. I do have another question for you whenever you're ready.
Go ahead.
All right. We have a question about the smallest bore that can be measured for surface finish. What is the smallest bore I can measure surface finish in?
So that depends on the size of the stylus that you have. So if I come back here into this part of the presentation, so if you were to use this 5 micron 90-degree tip, from tip to top of shaft is 20 millimeters. So of course you can't fit a 20 millimeter probe into a 10 millimeter bore. So that's heavily dependent on the geometry of the probe that you have. But at this time, we are able to fit a probe within a approximately 7 millimeter bore, as our smallest probe is 6 millimeters from tip to shaft.
All right. And I'm not sure if you're still working on getting your screen back up, but feel free to do that. In the meantime, I'm going to ask another question here. So, we've got an audience member asking about the positioning speed and accuracy on the CD140A.
So the positioning speed is variable. You can set it to as slow or as fast as you want. We can go as fast as 200 millimeters a second in the x-axis. The resolution of the probe system with the default probe is 20 nanometers.
Next question. I'm just going to read it outright. This is a fully optical measurement system. There is no probe physical contact with the surfaces. Is that correct?
No, this is not an optical system. This is a fully tactile machine. We do have other optical systems in our catalog, namely the Mahr CM line. That is a line of confocal microscopes that allow you to get measurements optically without having to contact your surface. So this is not optical, but we do have options for that.
Okay, we have a two-part question with two different stages within each. So I'll try and get this through as quickly as possible. The first question is basically, how often does this machine need to be calibrated?
So there's two different things that get calibrated here. One, there's the internal datum of the machine. That is what the probe system is sliding across as it's taking the measurement. That is something that Mahr generally advises is calibrated once per year on a regular basis. So for your preventative maintenance as well. So typically we recommend once per year on that. But then there's also probe calibration, which users are able to do on your own without a Mahr representative there. Like I said, it's very case by case how often you should calibrate. If you take 200 measurements a day, maybe you should calibrate your probe every other week. If you don't use it quite as frequently, maybe once a month is sufficient. But that's a pretty case by case basis and should be discussed further based on your application.
All right. next part of that is, what is the smallest metric thread that can be measured?
That depends on the probe as well. Um, at this point, I don't have that information um, for the smallest thread, but I can certainly look that up and see what the smallest probe is we have to offer, and then relate that to the metric thread size.
There you go. And for anyone watching right now that might want to follow up, you can see Nick's contact information right there on the screen. So last part of this question, are the metric thread dimensions pre-entered?
Yes, the whether it's metric or imperial, everything is predetermined. So when you put in those nominal values, um, it creates the geometry based off of the nominal values. So if you're measuring the same thread over and over again, you can save a preset selection of nominal values so that you don't have to input it every time you measure the same thread. You can enter those values once, save it as something unique, the name of your thread, and then every time you remeasure it, you can load those preset values to save time.
I'm curious, can you talk a little bit about connectivity options that your software allows between your measurements and any kind of quality management, quality control system? How easy or difficult is that?
So with Marwin, we can also do actual script programming. So we can really do whatever kind of export anybody wants. We just might have to create a custom script for that. And it also depends on what kind of program is on the receiving end. Can they pull a file from a specific location? Do we need to send a file to a specific location and then execute something else in order to get it to connect to the quality program? Or can the quality program grab it on its own without any other intervention between Marwin and the other program? So it is absolutely possible, but very application dependent based on how your the third party software operates.
Sure, that's cool. All right, looks like we have one more question, unless anyone else wants to chime in with a last minute question here. One more question, and it is, we've got a user asking if they can measure a 1-inch deep groove, or what is the deepest groove that they can measure?
Sure. So remember that while we have a 350 millimeter Z axis, that's not our measuring axis. So our actual measuring axis, we have 70 millimeters of range. So it is still dependent on which probe that you're using, whether or not it can fit inside the groove or not. But yes, the probe has a maximum deflection of 70 millimeters. So that would be the largest groove that you can measure. And 1 inch is well within that range. But as a maximum capability, looking about 70 millimeters.
That's great. Okay, that will do it. I want to thank Nick and the entire Mahr team for making this webinar possible. I also want to thank our audience for listening in. You should receive an email with the link to the recording soon. And that does conclude today's presentation. On behalf of Modern Machine Shop, I'm Brent Donaldson. Thank you so much for your time, and enjoy the rest of your day.
Thank you for having us, and thank you all for your attention and time today. I hope you were able to learn something. And wasn't sure.